to behave like particles or waves. All right, so a simple experiment, which was conducted here in Chicago.
And the evidence can still be seen today in the behavior of a gold leaf electroscope. When the electroscope is charged, the leaf rises and stays aloft until it's hit by a beam of ultraviolet light. An ordinary piece of glass transmits visible light, but it blocks the high-frequency ultraviolet light. When it's interposed, the electroscope doesn't discharge. But when the glass is removed, the leaf falls again.
All right, so ultraviolet is higher frequency than violet. All right, so this is charged metal, it's gold, which means that it's got excess electrons on it. And as soon as the electrons get hit by ultraviolet, they become energized and they jump out. They're liberated from the metal surface. As a result, the repulsion is made.
This proves that the ultraviolet light does the job, and it's called the photoelectric effect.
All right, so these experiments were first conducted here in Chicago, maybe about 15 miles from here, by someone named Robert Millikan. But before we discuss the history of it, let's talk about something else. Planck is the guy who discovered, he introduces the concept of quantization into physics, obviously in 1900, discovers it in 1899, presents it in 1900, publishes it in 1901. In the years 1905, he's in charge of this physics journal, research journal. And then he receives 2 articles from Einstein, same year. And this guy is, Planck is the editor-in-chief of the research journal, obviously. The first paper that he looks at is the photoelectric effect paper from Einstein. He looks at it, and then he puts it away. He marvels at the mathematics and how clever the paper is, and then he rejects it immediately. That paper is not going to get published. The reason why the paper is not going to get published is because of the underlying assumption. The assumption is that the energy is quantized, which means that the light is quantized. That's the underlying assumption of the paper. And Planck knows that you cannot make that assumption. It was already proven that the light is a wave, it's not a particle. So whoever this Einstein is doesn't really understand physics well enough to think that this paper is going to get published. All right, so Planck puts it away. That is a rejection. It's not going to get published. Except he's a little bit curious, so he doesn't understand how, with that underlying assumption, which happens to be 100% wrong as far as he's concerned, he doesn't understand how Einstein was able to solve the problem correctly. All right, so as far as he's concerned, it goes into a rejection pile. He's not going to look at it. That paper is not going to see the day of light of day, basically. The second paper is much more intriguing. He looks at it. That's about special relativity. So what happens when you're moving near the light speed? All right, so space is going to contract, time is going to slow down. It's a beautiful paper. He's looking at it, and he's amazed at the beauty of the arguments, the mathematics. And then he agrees with Einstein. I mean, Einstein ends up solving one of the biggest problems in physics. So his problem is related to what would happen if you were traveling at the light speed with a mirror in your hand. Would you be able to see your reflection? And he actually solves that problem. That paper is going to get published, and all of a sudden Planck realized that this guy Einstein is a genius. And so he decides that the special relativity paper is going to get published. So he goes back to the paper on photoelectric effect. And then he looks at it again, He says, you know, I completely disagree with the conclusion of this paper, but he decided, underlying assumption of the paper, but the conclusion is right on, because Einstein was able to solve the problem. He says, let's publish them at the same time and check to see what happens. So both papers get published. Planck mistakenly thinks that Einstein had a professorship at the time. This is 1905. Einstein was still working on his PhD, and shortly after, he could not get a job. So the Planck tries to get in touch with Einstein. By the time he was able to find Einstein, he was already working in the patent's office. Patent office is a second-class clerk. A couple of years later, he tries to get Einstein a job over at the Prussian Academy. Guys, you've got to remember, Planck is like one of the biggest names in theoretical physics at the time. He was well established in Germany. So he's trying to desperately get a job for Einstein. The Prussian Academy is one of the biggest places, highly prestigious places where Einstein could work. So he decides to mentor Einstein. To the Prussian Academy, he says, listen, this guy's a genius, hire him. He's going to be one of the biggest names in physics. Hire him. You won't be sorry, except remember, he's about 26, 27 years old. He's young. He doesn't know any better. He thinks that the light is composed of particles. Just overlook that. He believes in it. Just overlook that. If you just overlook that little detail, you will be very happy with this guy. All right, so Planck thought that Einstein got it wrong. And Planck wasn't the only person who thought Einstein got it wrong. There's another guy. This guy is from Chicago, Robert Millikan. He also 100% believed that Einstein got it wrong. So he decided to prove Einstein wrong by conducting series of Chicago, University of Chicago. Wanted to prove Einstein wrong. He believed, this guy's an experimental physicist, one of the best in the United States at the time, if not the world. He, from his experiments, he knew that the light was composed of waves. And he figured that Einstein got it wrong. So he decided to prove Einstein wrong, that Einstein's explanation of photoelectric effect was completely wrong. So he decided to conduct these experiments. The first set of experiments that he conducted during the year 1912 ended up proving Einstein correct. So, and then Millikan thought to himself, wait a minute, these experiments are not sophisticated enough. So he spent another year conducting experiments more sophisticated than the previous year. Once again, the experiments proved Einstein right. So Millikan thought to himself, nope, these experiments are still not sophisticated enough. So he spends the third year, the fourth year, the fifth year. This guy literally spends 5 years trying to prove Einstein wrong. So every single experiment ended up proving Einstein correct. So what happens at the end is Millikan, trying to disprove Einstein wrong, ends up proving him right. Take a look at these different metals. You got all these different metals, and notice that you end up getting a straight line for every single one of them. These are data points, straight line, straight line. If you're looking at the slopes of these straight lines, the slopes will be exactly the same as the Planck's constant, which means that the light is quantized, and the quantization of light is the Planck's constant. So he ends up proving Einstein right.
It was the perfect solution, and proved as such by Robert A. Millikan in his Chicago laboratory. When he measured the energies of electrons ejected from various metals by different frequencies of light, Millikan verified that while each metal has a different work function, Planck's constant has the same universal value for all of them. But this explanation of the photoelectric effect not only confirmed Planck's theory, it showed directly that bundles of energy already exist in the electromagnetic field. In other words, light comes in particles which are now called photons.
All right, so Planck proves Einstein right and wins the Nobel Prize in 1923 for proving Einstein correct. Einstein wins the Nobel Prize in 1922, a year earlier, because of the photoelectric effect. And his interpretation is the one that revolutionizes physics, starts modern physics, so to speak. So he also becomes the father of quantum theory. And thanks to Robert Millikan proving Einstein right, Planck ends up winning the Nobel Prize in 1918. All three end up winning the Nobel Prize because of Robert Millikan's experiments. So Planck, who did not believe that the light was quantized, did not believe that the light is a particle, ends up winning the Nobel Prize in 1918. Robert Millikan, who was trying to prove Einstein wrong, thinking that the light was a wave, ends up winning the Nobel Prize in 1923. And Einstein ends up winning the 1922 Nobel Prize for explaining the photoelectric effect. And then the underlying assumption of the photoelectric effect is that the light is quantized, which means that the light is a particle. Some weird shit happens. Robert Millikan went to his grave thinking that Einstein was wrong. He just couldn't come up with a sophisticated enough experiment to prove him wrong. Planck went to his grave thinking that Einstein was still wrong. He thought that the energy was quantized in the way it is actually absorbed and emitted by atoms. And he did not believe that the light was a particle. He thought that the light was a wave. It was just the interaction of light with atoms is where the quantization was taking place. Einstein went to his grave thinking that, what the fuck did I just do? What made sense to him when he was younger stopped making sense as he started to get older. The quantum theory ended up going in a direction that he did not agree with. It became probabilistic, as you will find out tomorrow. And he decided that he did not like that interpretation. And he decided to spend the rest of his life trying to disprove the quantum theory. And this guy, on the other hand, Einstein's physics professor, Philippe Lenard, vehemently and passionately hated Einstein, the man himself. Philippe Lenard is the guy who invented the photoelectric effect. And his student was able to explain the photoelectric effect, was able to revolutionize physics as he knew it. And out of professional jealousy, he turned against Einstein. He became an advisor to Hitler. He decided to start the Jewish physics versus German physics phenomena. A lot of the Jewish physicists end up losing their jobs, and they were lucky enough to be able to migrate out. And a lot of Einstein's books were burned. All right, so here's a picture of him from Wikipedia. I think it's probably Photoshop because what's missing is the two horns in a tail. And this guy is also put the United States on the map. All right, the reason why the United States is a superpower today is because of this guy. What happened was the United States was kind of like the United States in soccer today, which is usually no one takes the United States seriously because what does the United States understand about soccer? Nothing. The quality of play is getting better, but it's still not worth watching usually. People don't get it. And likewise, people didn't get physics in the United States. All right, there was backwaters of science in general. United States, no one cared about. It was like Canada, except it was bigger. It had no influence or name in the science of the world science in general. So what happened is because of this guy, a lot of the Jewish physicists had to migrate. Most of them end up going to England first, and then they end up in the United States, and those are the ones who actually built the atomic bomb. Those are the guys who came up with the atomic bomb idea, and those are the guys who built the atomic bomb, because mistakenly they thought that Germany was already working on the atomic bomb. So the investments were made. And the center of physics, center of power in physics, which now the sciences emanate from physics itself, end up shifting from Germany to the United States, and we still hold that power here in the United States, guys. And this guy is the reason why that happened, because he became an advisor to Hitler. And all these Jewish physicists, and physics is a predominantly a Jewish thing, end up coming to the United States. It's got a really interesting